Okay, guys, for this one, we're gonna go over assembly. I'm make this video for you guys' reference in the future, and for Lab 6, because for your projects you most likely have to do assembly. So, I'll make this video to go through a couple things, and we'll assemble the one for the lab. So first of all, let's start a new assembly. So we're gonna go start new and set apart. We're gonna go assembly this time and hit OK, and wait for this to load. All right, now it's loading in. In the meantime, let's review the assignment. So this one, we are recreating this vise and it has to look exactly like this. So in this lab document itself, for each of the parts in the paragraph description, it will tell you the location of each of these parts and how they connect with one with each other. So we'll go through those as we go through this lab. So of course, when you first start a assembly, you're always gonna have this pop-up window, right? For the whatever parts you want to bring in. And if you already have your parts open in SolidWorks, it will open up in this window over here. If not, then it will open up in this window, pop-up window, and just select what you want. So of course, we're gonna select all our parts, right? So I'm gonna select all of these because we need to bring all these in and hit open. So like I said in lab, the, okay, the first part is always going to be your fixed part, right? So like I talked about, when we make 2D drawings, you always want your sketch to be centered on the origin. So at least you have a part for reference, right? So same thing for assemblies. Your first part is always going to be fully fixed, and this is your starting part. This is what everything else is going to be based off, and it will be pulled towards. So to start, I'm going to put everything in the general area that it's supposed to go. We should be putting in 6 parts, but we need 8, right? The vice screw. So again, like I said before, so for the key parts, right? So looking at our assignment, of course, we know that we need 2 keys that will go right there, and then 2 handle caps. So of course, these 2 keys, right? We need those 2. So let's put those. So again, like I said, if you want to make a second part, you don't have to make a new part completely. You could just bring over that file. You can have as many of these file parts as you want in your assembly. So I'm going to go insert a component, go to browse, and then I'm going to bring another vice key over, right? So I have 2. And like I said in lab, if you guys don't want to browse for what you want, you can just hold control and click and pull the part you want to duplicate, right? So it works for all parts. You can do that. So let's start first. So again, since everything is not mated, has no dimensions, all these can be moved freely, right? All of these except our base. And why is that again? Because again, like I said, the first part that we bring in is always going to be fixed. It's the part that gets built on everything, right? But for example, if you wanted to use a different part, let's say I wanted this to be my fixed part, right? All you have to do is right hand click, fix. And what does fix mean again? Fix means you can't move it, it's stuck in place, right? So now that component's fixed. And if you want it unfixed, right click again and hit float. And now it's floating in open air. So same thing for this part. If I didn't want it to be fixed, I can make it float, make it wherever I want, but I do want this fixed, so we're gonna put it back to fixed, right? So let's start. So first we can see that, let's make this part first, right? This little sub-assembly. The keys are supposed to be part of the jaw. And then it says that the keys fit into the slots of the jaw with the edges flush shown as in sub-assembly shown below, right? So we're gonna make those flush. So again, to mate, we're gonna go mate, right? And you have all these relations. You can either be coincident, perpendicular, parallel, tangent, concentric, lock. So for the most part, for this lab, I think we only have to use coincident and concentric. Those should be the only ones you need to use. And typically those are the only ones you ever really use in assemblies, I would say, because it's the most simple. And usually you only make assemblies for visual purposes. So we're gonna hit that face, and I want this face to touch, right? So we're gonna hit those 2 faces and make sure it's coincident and say yes. So now on that plane, those 2 faces always touch on that plane, right? So now I'm gonna lock this face and this face together, right? So I'm gonna hit those, coincident, check mark. So now we know that this is also locking on that plane, right? So it can only move forward and back now, right? But it's supposed to be flush. So what flush means again is that 2 things, it's like at the same level when you flush, right? So if you push a screw into the wall, if you want to flush, that screw will be perfectly on the wall, perfectly flat. So what that means is this face and this face are going to be on the same plane. And now this is flush, correct? Yep, that's correct. So now we're going to do the same thing for the other side. Same thing, right? We want those faces to touch. I'm going to hit check mark. I want this face and then the bottom of my key to touch, check mark, perfect. And then this face and this face coincident as well, right? So check mark, perfect. And now those two pieces are fixed together in one part. So now we go look at our assignment again. It says that the shoulder of the jaw rests on the flat surface. So this is the shoulder, right? And it rests on the flat surface of the base. So what that means is that this shoulder, the bottom, right, is supposed to sit flat on the jaw right here. So now we want that this face and that face to be coincident so they're on the same plane, right? So we can hit check mark. And now we know no matter where we drag this, it'll always be on that plane, right? If you rotate it from different angles, it's always on that plane. No matter where you drag it, it's on that plane, right? So now we want to dimension it more. And I think it should be this face. And then my inside face right here should be coincident as well, right? So now our jaw is perfectly in that slot, right? And you can double check, right? So this is what assemblies, like I said, are used for, to double check our work. So if you made all your parts correctly, it should fit perfectly together, right? Whoops, left face, right? It should fit perfectly together, right? Right here, how the keys fit perfectly underneath my base. So if you made it correctly, it should fit perfectly underneath. If you didn't, I would say double check your individual part drawings or double check the features, lines, spaces that you clicked when you were mating, right? So the last part for this jaw is that it says the jaw is open. The jaw opening is set to 1.5 inches. So we're going to set that relation, right? And again, mates are essentially relations, but in a 3D aspect. So we're just going to use these relations. So we're going to use the distance relation, and it's supposed to be 1.5, right? So we're going to make 1.5, and it's saying that this opening is supposed to be 1.5 inches, right? So then we can set from this face to that face. The distance between those two is 1.5, right? And check mark. So now all of this is fixed and fully defined. So that's really good, right? So let's move on to the next part. Let's go to what's next, the screw. So let's read your assignment. This is one chamfer edge. So it says that the flat of the 0.75 edge, which is this side of the screw, is flush with the corresponding recess of the face of the jaw, and that is this 0.75 recess, right? That hole, right? So it's supposed to be flush as well, right? And of course, flush means it's perfectly together touching. So first, let's make these two parts concentric. So when we use concentric, we just hit the circular face, right? You can hit the line, but again, I prefer to use faces because it's just a bigger area for you to touch, and it's just more clear than using a line because again, those can rotate in 3D spaces. So to make it flush, we're gonna hit the back of that hole and this face. So now that they're touching, right? And we can see the transparency of our part right now, how those are touching, and it goes inside the hole. So we can check mark, and now perfect, it's flush, right? That looks really, really good. And this is fixed in place except for the rotation, right? So let's keep putting it. So we know that this part is going to go in here. So again, hit those two circular faces, make it concentric, perfect. Let's just drag it down a bit, right? And then we know that, what is that? That's supposed to be set at what, 30 degrees? So handle rod. So the handle rod passes through the hole of the screw and is rotated at an angle of 30 degrees, right? So what does that mean? That means if you look at it from this face, let's get out of our meeting. It means that this rotation from here to here, this area should be 30 degrees, right? Not down here. Whoops. Go left. This is supposed to be 30 degrees, right? And of course, when you make an angle, whoops, 5. Whoops, I hit F4, that's why. Ha 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 ha. Okay, again, so we want it here, right? So when you guys put an angle, you can't make an angle using a circular face, right? Because it's saying, oh, where's the line we're comparing it? If you just say the circular face, what part of that circular face? Because if you have a circle, a plane can be tangent to that circle surface on the whole thing. So that doesn't make sense, right? So when we use an angle, what we're gonna do and what I did, I made a center line inside my part here, right? So to do that, you can click your part, then right hand click, and then in this folder, open your part, right? So that it's going to open your part for you, and then you can edit your part separately from the assembly. And you can also edit in the assembly, but I would recommend that you guys don't do that until you've developed more skills and feel more comfortable in assemblies, because you might get confused. So in this case, what did I do, right? This sketch 2 I made right here. I sketch on my top plane, right? And I made a sketch, right? Just straight down the middle, right? So then I made that line. Then we can exit sketch and then always save. And then go, whoops, go back to our assembly, right? And if you get a pop-up that says update the assembly, always say yes. It's because you made changes and your part needs to update within your model as well, right? So hit yes. Now we can use the line I made. We're gonna hit mate and this edge, and we can use this angle feature and put 30. Perfect. Looks really good, right? So now that's set at an angle of 30, perfectly fixed. So that's good. So the next part, we're gonna put the handle knobs on our handle knobs on the handle rod, right? So we know that this should be concentric, right? A concentric mate, so that's lined up perfectly. And then it's supposed to be this inside face and this face are supposed to be coincident, right? So check mark. And now let's do that for the next one. This face, this circular face, that circular face, right? And let's drag it out. Then hit this face, and of course, it's this inside face. So again, right? This face, it is coincident. That's true, except it's on the wrong, it's going the wrong way, right? We want it to flip. So to do that, we just hit flip mate alignment, and now it's lined up correctly, right? Okay, right? So again, so when you have a coincident mate, coincident, it just means two things are touching, right? Two things are on the same plane. But now we're in a 3D space. It's not just 2D anymore where you say, oh, this dot touches this line, right? Or these two lines touch, right? It's not the same anymore. It's a 3D space. So when you do coincident in a 3D space, you have two options, right? So let's say this is the top and this is the top, right? So when you say coincident, it's either going to be that your two parts are on the same plane, which is this top plane, the top of my hands, right? Those two planes line up, that's a coincident mate. But if you flip it like this is also a coincident mate. So you have two options with coincident, right? Because it's just as long as these two plate faces are on that plane. And again, that plane can go both directions. So it could be my two hands go this way, two hands go this way, two hands go like this, or two hands perfectly underneath and on top of each other, right? So just remember that. So anyways, so now that we fixed that, we can say add. And I think the last one to put is right here. So the handle is aligned with the screw so that the outer edge of the upper knob is 2 inches away from the central axis, right? So what does that mean? That means that this top of the screw, right, is going to be 2 inches away from the center axis, which is here, right? And we go back to a distance dimension again, 2 inches, check mark, right? So good. Perfect. And again, similarly to what I did for the handlebar screw, I hit that face, hit open part to edit it. And what did I do? My sketch 6, again, on the top plane, all I did was draw this point sketch and made it concentric with this cut, right? That's what I did. And again, so you can draw that, save, exit, go back to your model, fully update it, right? And then use the 2 inches. And now everything is fully fixed, right? And if you look at it, everything's aligned, everything's fully fixed. So that means this part's fully defined, right? So that's really good. So now put an ISO view and let's compare our two drawings. Let's compare our assembly with the drawing. And that looks really good, right? It's exactly the same. Perfect, right? So that's part 1 of your guys' labs, right? So part 2 is exploded view. So exploded view, we can hit exploded view in the top corner, right? And again, for exploded view, you can either select multiple pieces at a time, and it'll drag them all out, right, together. Or if you don't want to do all that, you can go one piece at a time, right? And hit done, right? For each step, you can go one piece at a time, hit done, right? One piece at a time. But to make it easier for myself, I'm just gonna hit all my parts. Make sure I hit all my parts. Don't forget your keys. Whoops, not my base. Don't forget your key pieces, right? Because we need to move them all, explode everything out, right? So we're gonna explode that out. Okay, let's move. Okay, we're gonna hit done. And then let's separate this from our handlebar. So let's move those two out. Done. And then our keys, let's move those out too. So the reason I hit done and not check mark, right, is because if you hit check mark, you're gonna finish your explosion completely. But I don't want to finish my explosion because I still have things to do, right? So you only hit done, you're making steps. And what steps does is that in your animation, when you explode it, it goes each step at a time, right? So this chain one, step one, chain two, step two, chain three, step three. In your animation, it'll pull those parts out first until to follow each step through, right? So now that I'm done, I can hit check mark. And if you guys accidentally hit check mark instead of done, it's fine. You can always edit your explosion. If you go to your feature tree, go over two spaces to your configuration manager, and now you have your assembly and default. You're gonna hit the down arrow on default for exploded view one, right hand click that and just hit edit feature. And then you can add more explosions. If you forgot any, add less, right? And then again, just hit done, and then check mark once you're done with everything, right? So the last thing you guys need is flow lines. So to add flow lines, we're gonna right click and then hit Spark Explode Lines. And then just those lines are well enough and just hit check mark. And now you guys have explode lines, right? And then don't forget to put it in ISO view. That's everything. So some couple things I want to go over is that if you want to close your explosion, right? You go back from config tree to your feature manager tree, right click and collapse right here to go back into your close ISO view. And if you want to explode it, you right hand click your assembly and hit explode, right? So again, you can animate the collapse, right? And this is where your steps comes into play. So it animates each of those at a time, right? So if I want to animate my explosion, so you guys can see how my first step, all this came out, right? Second step, I have to move my handles out. My third step, I have to move my keys out. And the fourth step, I move my jaw a little bit more, right? So that's where those steps come into play. It's for animation and visualization purposes. So again, the reason why I'm so strict about you guys with orientation, why I tell you you need to pay attention to your front face and blah 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 blah, right? Is because every time you insert a new component, it's always going to be in isometric view, right? So again, since I drew my part where this is the front, this is the right, this is the top right. It gets imported correctly, right? But let's say you guys accidentally made this the front, made this the left, right? And then made this the bottom for some reason, right? It's completely fine if you guys accidentally do that. You can still fix it. So when you insert your component and choose where you want to insert, right? Before you hit the left button, hands up, before you hit the left button to place your part, right? You're gonna right hand click on your mouse. Right hand click on your mouse, and now you can rotate your part, right? So again, let's say you foolishly, let's make this upside down and then let's rotate this more, right? Let's say you foolishly made your part like this, right? Where that's your top, that's your front, that's your left, right? It's completely wrong, right? If you do that, it's fine. You can always fix it. It's just, it saves you a lot of time, saves you worry. For the assembly part, it's more important for drawings, which we'll get to next week. But if you mess up, right, it's fine. Just before you place it, just rotate it till you have the correct orientation you want, right? And now you have it, right? And let's say you place it already, right? And let's say we want this face and this face. They're supposed to be lined up correctly, right? You can actually use mates to realign a part, right? Sometimes you need to get it correctly, or like the mate, it just automatically won't take it because of the orientation of the part. And that's true. Sometimes it just won't work, right? So we can use mates to realign some stuff, right? Let's say I want these to be perfectly straight together, right? I can hit this face and this face and tell it to be coincident, right? Or parallel, right? And now it's the correct orientation, right? And that's perfectly fine to use to realign something. Just remember you go back and delete that mate because you don't actually need it, right? It was only to fix it because I want it in the correct direction, right? So you can do that too. And I think that's everything to cover for this lab. So guys, don't forget ISO view, and don't forget ISO view close, and then don't forget ISO view exploded. And of course, remember ISO view spacebar, and remember you're on isometric because there are three different views. There's trimetric, right? Or dimetric, trimetric, and isometric. So remember you need to submit isometric. Some people have been accidentally submitting the other two views. So always double check that in case your SolidWorks resets its settings and it's not saved. And of course, don't forget your, where is it? Evaluate mass properties, your mass properties for your vice volume, right? Cool. And that's about it. Good luck on the lab, guys.